Okay, so talked earlier about EX zones, and these are digesters on our tanks. And the picture on the right is the EX zone. So we obviously, because these are digesters, they've got methane gas in them, they can be explosive. We've got to be aware of every task on every site that's got an EX zone, and we've got to make sure we're outside of that. So we make sure we've got the drawings for the EX zone, and then we fly a good sort of 5-10 meters away from that. The good thing about the M300 is because it's got a 200 times zoom lens on it, you can do the same job from further away, and it's much better quality. And the picture on the left, I just wanted to give you an idea of size, of scale, really, and just point out on the top left-hand corner the little chap that's there. And that just gives you an idea of scale of these assets. And this is where we start looking at, because one of our jobs is, and we'll show you the pictures in a couple of pictures in a minute, is to investigate the inside of these digesters when we do some work on them. So we'll clean them out, we'll vent them out, and then we need to inspect the inside of them. Now, this used to be done by scaffolding and throwing people in there to do it. Now we can do most of that. We don't do all of it, but most of that with the drone. And that means, we're saving a fortune, but we're not sending people into effectively confined spaces at height. The problem that we found is we use the Helios for this, but as you can see from the size of these tanks, the Helios isn't designed for, it's designed for confined spaces, not large spaces, if you like. So what we've done is we use a Mavic, which is amazingly stable in these areas. The Mavic does all of the walls, so there's 64 cubic meters or something of wall. There's a massive amount of wall. I think these are 10 meters by 20 meters, these tanks each. So the Mavic does the walls, takes the pictures of the walls up and down all the way around, and then we use the Helios for the roof and the really tight spaces on top, because it gives us that much more leeway. So we use a mixture of the two for there, but we found that the design of the Helios isn't ideal for taking pictures of massive straight walls. It's just not there. I'm sorry. So next picture, please. So this is a picture from the Mavic inside the tank. Probably not the clearest one, because what we do is tend to just leave it on video and then just run the video constantly rather than taking lots and lots of pictures. But you can see this is a totally dark tank. So the lighting gantry on top of the top of the Mavic gives us enough light. We can focus in, we can look at obstructions, we can see, I don't know how clear it is on your screen, but we can see there's some imperfections in the wall on the left hand side there. And it gives us a really good view of the tank itself, and again, over time. If we go to the next slide, if we look at the difference then with the Helios, so now we're looking at the roof, we're looking at cables coming through the roof, we're looking at how the roof is, is made up, and there's lots of little pieces in there, or lots of things put together, and making sure that's right. But if we go to the next one, when we start going up, now you look at that, and that's the same tank, and it looks concaved. Oh, sorry, it looks convex rather than concave, because that's just the way the camera is set up on the Helios. So if you can see it, the roof wall, or the joint between the roof and the wall, is at the wrong angle. So that makes it difficult to look at when you're looking at things in the right way. But that's only because of our use, how we use it. One of the other things that we struggled with the Helios was inside these massive tanks, if there's any openings on the tank, you get a jet of air going in, and that knocks the Helios out of its stream, whereas the Mavic is perfectly still in all situations. So we've got the Helios. It's a brilliant piece of kit. We probably use it in the wrong places, but we've got it, and we'll keep on using it to maximize its efficiency. But the 4K images are brilliant, so we can see on that particular image, the link between the roof and the walls. The walls themselves were, stuff's peeling off, and then any fixings, things like that, we can pick them out really easily. So You know, everything we do there is an amazing piece of kit, and it's a massive step forward for us. So next picture, please. So now we're going on to 3D modeling. So we've gone from taking comms pictures and taking pictures of dam walls. We're now looking at 3D stuff. So this is just a picture of from Google Maps, which shows Google Maps 3D of an inlet of a works. If we go to the next picture, this is our picture. We've been working with a company called Stantec and Team UAV down south, and we've managed to get these pictures from 3D, and these are total 3D maps, so you can look around in all directions, focus in, run through, do and any of the assets, and they're pinpoint accurate. So you can give these into a CAD drawing to a contractor, and they'll be able to build on the back of these on these maps. So the accuracy is fantastic, and this is all from modeling from drones. It's a huge step forward for capital work, and we're looking to do all of our schemes next time possible. That's the moment we're looking to do that in this same manner. So literally, you can do a quick 3D scan of the site. Look, we use Bentley software at the moment, and we get really accurate pictures of the site. It's an amazing tool for things like training, where you can train someone on the site before you actually let them go on the site. It's that accurate and that clear. It's an amazing step forward, is this, and one that we'll be concentrating on in the next few years, and no doubt. Next slide, please. So now we're looking at thermal. So the picture on top, the Mavic Enterprise has a thermal camera with it, and the same as the M300, it takes both pictures at once. And you can see when we took a picture of a roof on the top, it took exactly the same picture with the thermal camera, a little bit blurred, but what you can see on the bottom picture is there's obviously some ingress. We wouldn't have seen that ingress on from the outside. You just don't see it, but you can see there's obviously clearly something getting underneath the roof line in there. And given that it's a clean water site, it was absolutely critical that we investigated that and found out what the cause was. So just looking at basic structures like roofs, it's the equipment that these things for 4 or 5 grand, the Mavic Enterprise, it's amazing what you can find. Next slide, please. Right, so this is the difference. This is the M300, and that just shows you the difference with the thermal camera that comes with the M300. It's chalk and cheese, really. So we've got a pump set here. You can see the pump set. There's on the left-hand side. There's a fan. You can clearly see the pump set's nice and warm because it's running, and everything is cooling in the right place. Looks okay. If you go on to the next picture. Now, for me, I'm not a proper engineer, but I can see that the fans obviously fail because that's very, very hot. In fact, the motor's so hot that the electrical kit is also hot, and there's obviously that's a potential fail. So just a quick 2-minute flight over some pumps has already, highlighted where a potential fail is on our equipment, and it's very easy to find. Once you know what you're looking for, it's really easy to find. Next slide, please, and this will be the last slide, I think. So this is, again, using the M300, 5 blowers in a row. I thought there was a fault with one. Turns out there's a fault with 4 of them. And the one I thought was a fault was wrong. So the one on the top left-hand side, that's the one that's working perfectly. It looks a bit weird, but so you can see the blower. You can see the air end on the back is nice and hot. You can see there's a space where everything's allowed to cool down. You can see the jets of air or the air on the outlet. So that's working fine. The one on the right is working, but it's a lot worse, and then it gets progressively worse. The next one in one on the left, and then the center one is hot all over, and that's definitely a potential to fail, that one, and that needed investigation. In fact, all 4 of those needed investigation. But it's not until we took this picture and shared the images with our engineers, electrical engineers, and they went, wow, there's something not right there. So that's where we're going at the moment. You know, the M300, the thermal camera on there, has given us a completely new view of how to work, especially from an engineering point of view.